Website speed is a feature. Web performance optimization, developed with Google, explores performance patterns for world-class site speed. Dive into the critical rendering path, uncovering how browsers convert HTML, CSS, and JavaScript into actual pixels on the screen. You'll learn how to leverage recommendations from PageSpeed Insights and data from Google Chrome's developer tools to immediately boost website performance. For more information, visit udacity.com/Google.
Hello and welcome to our Ask the Expert session for our Google Udacity Web Performance Optimization training course. The course just went live a couple of months ago, and I'm here with the instructors, Ilya Grigorik, developer advocate at Google, who wrote a book on web performance, Cameron Pittman, a course developer at Udacity, and I'm Peter Lubbers, a program manager on scalable developer training. So in this Ask the Expert session, we're going to cover a little bit of the basics, why performance matters, what the critical rendering path is and what it has to do with performance. Then a little bit about the tools that you need to measure. One of the big things in your course has been measure first and then optimize. So how do you measure? And then we'll answer all the questions that have been submitted in the moderator. So let's start with the basics. Why does performance matter for web pages and web apps?
Sure. Well, I don't think any of us like staring at a blank screen or waiting for the next page to load, right? So it should be a pretty simple one. But it also helps with conversion, user engagement, more page views. Simply put, speed is a feature. And for many apps, it is the killer feature. Think of something like Google Search, where speed is one of the primary features, on top of obviously good content.
Right. So then the course targets the critical rendering path part of performance. There's many aspects, and one of the nice things about this course is very short. I actually have to admit, I just took it yesterday in preparation.
Nice.
So one of the nice things about that is you can take it in literally an afternoon or an evening, and I've really enjoyed it. So tell me a little bit about the critical rendering path. What is that, and how does it relate to performance?
Yeah, well, like Ilya said, nobody likes staring at a blank screen. And so, some websites, they'll load, the screen will be blank, and then all of a sudden everything will appear. But other websites do a good job of rendering progressively and, showing more and more content as time goes on. And essentially, the critical rendering path is the set of steps browsers have to take to load websites. And the course is all about, understanding that set of steps and manipulating it. I like to think of it as sort of a game. The steps can happen in different orders, and they're tricks to the way you develop websites to make pages render progressively and as quickly as possible to get those first pixels on the screen in as little time as possible.
Great. Now, measure first, optimize later. To measure things, you need tools. What are the tools, the go-to tools for you in this course?
We cover a lot of different tools throughout the course, so you get to interact with different tools actually as you go through the course. But in particular, I think we focused on Chrome DevTools and PageSpeed Insights.
And particularly the timeline tab in Chrome DevTools.
Sure. Yeah, there's a lot of other features in there.
So the timeline gives you kind of a low-level perspective into everything that's going on in the browser. And to be honest, the first time you open it, if you haven't seen it before, it's going to be very overwhelming because you hit the record button and before you know it, you have like pages and pages of events with cryptic names like layout and parsing this, parsing that, and it's very hard to understand what's happening. And the intent of our course is to first explain those concepts and how they relate to performance such that you can optimize that loading sequence.
Yeah, I liked a lot of the sort of the answer videos for the quizzes and how you, for example, would uncheck a little box and all of a sudden made some sense out of this massive amount of data.
Yeah, you can filter, by what types of events you want to see, and filter it, time-wise, see, chronologically, you can decide what period of time you want to investigate further.
Right. Yeah, so definitely check out the course. If you haven't taken it, it's on udacity.com/Google. Look for the Web Performance Optimization course. A lot of great tips and tricks, and it is a fairly condensed course. You can
optimized.
Highly optimized. So let's talk about some of the questions that the students have added on the moderator. And we've also posted some of the answers in the moderator themselves. We've added some links. So definitely if you've asked a question, go back to the moderator and look at some of the detailed answers that are in there. But we'll cover that in this session as well. So let's just dive right in. The first question is from Juan, the top voted question. Can you share some real numbers of the differences when serving a site via pure HTTP speedy, HTTP 2.0, quick. For a simple page, there doesn't seem to be much of a difference. At what point does it start to matter that you use all these newfound
So
ways?
this is a really interesting question. We don't get into this in the course in terms of like how do you deliver resources over these different protocols. So for those that are not familiar, HTTP2, HTTP, speedy, quick are all different variants of how the data actually gets delivered to the browser. So in terms of actual real numbers, HTTP2 and speedy are basically the same-ish. HTTP2 is still in development, so it's really hard to talk about real numbers because really we don't have production experience. For speedy, I've shared a link in the answer there. On average, for Google services where we deployed speedy, we see an improvement of somewhere in the neighborhood of like 30 to 40% in terms of delivery of resources.
Right.
So you get them 30 to 40% faster, which is nice. Now, the question about like what's a simple page is kind of a tricky one because I'm not sure what that means. When I look at something like HTTP Archive, an average page today is like 60 resources and 2 megabytes in size, right? So is that a simple page?
Yeah, or is it one of the ones you use in the course to demonstrate like the hello world type examples?
Right. So I think it depends on context. You should measure.
Yeah.
Then optimize.
Then optimize.
Got that.
So yeah, I think that's where you start. And for quick, I guess I should say, that's also still in development, so we don't have any kind of production numbers. If you're curious, we actually have quick enabled on some of the Google services. So when you access it, it runs over quick, but it's still mostly at a stage where we're trying to make it work right, not make it fast.
Right. Well, and I think anyone can basically take their page, however simple that may be, and run it through PageSpeed Insights, see if you can improve it and if it's worth it. The effort, I guess. So there you go. So the next question is from Stuart Memo in Glasgow, Scotland. So that's great. We have a lot of international questions here. So is it better for me to have one large CSS file that gets cached for all pages? And this is something that was specifically covered in the course. Or should I have a base file that gets cached and have smaller per page files? I remember you talked a lot about inline some CSS and JavaScript, and so is there some general guidance?
You know, I think, yes, the general guidance is measure first, then optimize.
I get it now.
Yes. You know, it depends, right? In some cases, you know, if you want that first page render to happen much faster, it's probably a good idea to inline the CSS or just deliver as little as possible. But if you think a user is going to be on your site for a long time, maybe navigating to different pages, maybe it makes more sense to deliver the large file and cache it. But it depends. You got to measure first.
Yeah, that makes sense.
One thing I would consider when you think about small files or larger files is what's the content of those files. So let's say you have 5 files and some of them are updated frequently and some of them is like a library file that is just static, you never touch. Right. If you put that all into one bundle and then you update that one little bit in the file that changes frequently, you have to re-download the entire bundle, which is actually inefficient. Right. So you would actually get better cache reuse if you separated them. So those are the kinds of things that you need to kind of play with. And also on different pages, let's say you can separate the logic and say, I only need these functions on that page. Well, to me, it makes sense to load only those things on that page.
Right.
So unless you're running into or unless we're talking about dozens and dozens of script files, I wouldn't really go as far as like bundling it all together. Like if you have a couple of script files, that's fine because we can download those or the browser can download those in parallel. And especially coming back to Speedy and Quick and HTTP2, those restrictions don't exist anymore. So we can download as many files as we want as quickly as we can.
Yes. Perfect. Great. Well, next question is from Yorgos in Greece. I'm developing mobile web pages for markets with slow mobile internet. My impression is that HTTP compression inhibits progressive rendering and that gzipped pages take longer to start showing. What gives?
I'm not sure what gives, because that's unexpected. I would not expect gzip or HTTP compression to affect this in any way. Perhaps there is a really slow server and it's having a really hard time trying to compress data, but that seems silly too because compression's pretty darn fast. And
so in general, you would say this, let's say, shouldn't be a problem. Of course.
In fact, compression should help because by reducing the amount of data you need to ship, that data should arrive faster to the browser. At which point the browser can stream decode
Yep.
gzip data, right? It doesn't have to wait for the entire file to arrive.
Right.
So there should be no reason, short of like, it takes a long time to generate the gzip asset for some reason.
So maybe a good thing, Yorgos, is to really measure using the tools in the course what's actually happening and come up with some more detailed analysis of
Yeah,
this.
perhaps the
because-
first thing I would look at is open up the network waterfall and just compare with gzip on and gzip off. Like, is there a response time difference in how long it takes to fetch that?
Right. Yeah.
Because
Right.
my only guess is it has to do something with the server.
Okay.
There's nothing in the browser that would make that statement be true.
Yeah, exactly. Hopefully that would be true.
If there is, then there is a bug, and you should let us know.
Yeah. Right. Cool. Which you can do. You can file bugs specifically against Chrome. You can use the
crbug.com.
crbug.com. So, next question from F. Goldenstein in Buenos Aires, Argentina. So we're going all over the world here. If you have to get many different entities from the server using Ajax on document ready, is it better to make one request to get one big object or multiple requests? So kind of a little bit similar. Of course, we don't know, are these entities in-page updates? Kind of, let's say, if you're polling for data, clearly you shouldn't even be using Ajax. Any ideas here?
I think the advice is pretty similar to the CSS question as before. You gotta measure. You know, depends on what you're doing, and if you are going to be using those files later, cache them. That's great. But like Ilya said, if you're going to make a change to one small file, they're batched together. It's probably a good idea to separate them. Otherwise, you'll be, unnecessarily updating and re-downloading files.
I think it's same advice. To me, cacheability is always a big thing. Like, can I cache this individual bit and reuse it later? And whenever I merge multiple things, chances are that's going to hurt your cacheability.
You speak a lot about caching. Maybe you should do a course on that.
That's an interesting idea.
Just throwing it out there. All right, so Sergey Kurtenko, he's asked, are recommendations about reducing critical rendering path universal for all browsers, or is it browser specific? For example, something that works well in Chrome may affect things negatively in Firefox. Fortunately, I think it's the same for everyone, right?
The steps are identical across all the browsers. So in fact, that's the HTML5 standard, right? Which specifies, for the first time, actually, right, how, given a document, the browser should go about processing it. So in which order, for example, like you have an outstanding style sheet, and then we need to execute a script. That's a parser blocking script, and we need to block and wait. So those steps are in the spec. All the browsers should do the same.
Yeah, and it's actually a little known fact that is part of the HTML5 specification.
Right. That is probably one of the most awesome things about
Exactly.
HTML5 specification, aside from websites.
And that's why I got the license plate.
Exactly. That's true. Do you also have the HTML6?
I actually do, yeah.
Really?
It's in the parking lot right now.
Nice.
I just figured,
Eventually.
you never know when that comes in here. So, all right, so at least there shouldn't be any, but are there any specific, or there's always some browser-specific stuff that's happening.
So there's a difference.
Have you seen any differences?
Yeah, so there's a difference between the kind of algorithmic steps that should be taken in terms of like what order things come in and implementation. Right. So there could be bugs, there could be kind of different rendering engines that do things slightly different. You may not get the same kind of ordering of events, kind of individual events, but overall it's the same process. So if you follow our advice in the course and you're using Chrome Timeline, you should get an improvement across all of the browsers because it's the same stuff.
Perfect. That's great. All right, another question from Light in China. These lessons seem to focus on network. Is there any other advice on layout and paint? Actually, I do remember some paint advice in there.
Yeah, we touch on paint.
You touch on it, yeah.
So the way I think about
another future course, maybe.
Yeah, definitely.
Perhaps.
So for the critical rendering path, the trick there, so the way I think about kind of the overall sequence of web performance, right, is you need to deliver a first frame really fast, and that's what this course is about. Then after that, you need to update it at 60 frames per second. Right, and that's kind of the layout, paint, and all the rest. So there's also layout and paint in that first frame per second, and we cover it in pretty good detail in terms of like what is a layout to begin with, or how do we paint things. We don't get into the details of like how particular parts of the page get invalidated, because that's not really what painting the first frame is all about. But the reason we talk quite a bit, I guess, about network is that first frame also needs the resources, right? Like, I can't execute the JavaScript until I have the JavaScript, right? And actually, we know that based on Chrome data, we ran an experiment. We reloaded the top 1 million sites ranked by Alexa rank. And we found that 70% of the time, the browser is just sitting there idling, waiting on the network. Right, so this like, I would like to do something, I would like to paint, but I can't because I'm stuck waiting for this render blocking CSS or something. So that's why we spend so much time talking about why the order matters and why you want to kind of get those resources down to the browser as quickly as possible.
That's great. That's great. All right, we have a next question from Virginia, Jonathan Garby, who is one of the Web Platform Docs contributors. Do you know any ongoing work or discussion to alleviate the trade-offs between security and performance? Both are obviously important. For example, if a site owner enables CSP, the content security policy, then they currently can inline CSS for above the fold content. I thought that was a good, interesting question. I'd like to hear your take on that.
So it is an interesting point. The recommendations that we give, when you inline content, that is actually potentially a way to attack the site. So let's say you can inject content. So CSP provides a way to set a policy that says anytime you see inline content, don't execute it. Right? And that is actually the recommended policy, because that kind of locks down your page, which runs counter to advice. But thankfully, the spec actually has a section on declaring a nonce. So what it means is, let's say you have a script, an inline script, right? What you can do is you can take a checksum of that script when you inline it and say, like, this is the SHA checksum of this thing. So if anybody modifies it, if somebody other than me modifies it, you can detect that. So that allows you to both have the inline script and still enforce that policy.
Well,
alternatively, you could just like relax it completely and say, it's okay for me to execute specifically inline CSS. Like, you can set that in your policy.
But certain companies may have a default policy that you can't override.
A better strategy, a more secure strategy would be the nonce. So there shouldn't be that trade-off, right? Anytime we see a trade-off between performance and security, that's not a good outcome. So we try to make sure that both work together.
Okay, so you've effectively found a way to inject performance.
Right. You can have security and performance.
Best of both worlds. Everyone's happy. So great. And I noticed you posted a few links, or a link in the moderator.
So we'll leave a link to the spec in the right section in the spec for that.
Perfect. Cool. Hack Tushar in Rajasthan, India asked, how can we improve performance and compatibility of HTML5 web and hybrid-based mobile apps over native apps? I guess that means things like PhoneGap or WebView-based apps. Is there any difference? Are there things you would do differently for content that is in a hybrid app or rendered in a web view?
Still being rendered in essentially a browser, so the critical rendering path will be the same.
All the steps are the same in terms of improving performance over time and extensibility. It's to me, that's more a question of, are you using the latest rendering engine that has all the latest bells and whistles and all the latest optimizations? So, if you're building a native app, that's something you should consider. Like, what is that rendering engine that you're using under the hood? Recently released Chrome WebView, which has all the goodies that Chrome offers.
I guess a lot of this is even more important for mobile apps where bandwidth isn't, you're not on your desktop. So. But the
I would say actually the majority of our course is focused on mobile, because this stuff is critical for mobile, because the network is slower in terms of latency on mobile, so you end up staring at the white screen for long periods of time. That is just not a good experience. So that's also why when we talk about the screencasting mode and kind of capturing traces, we encourage you to do it on your phone. Like, don't connect to your Wi-Fi, disable your Wi-Fi, fetch it from a real network, and get it from a real device, because that's totally different than you being tethered to like a fast gigabit network on your desktop machine.
Yeah.
So use dial-up, right?
Not dial-up, but
You got to feel the same pain your users might feel.
That's true. That's true. Well, there was a question earlier about the sort of from Greece, right? He was developing.
Right.
Yorgos in Greece was
although,
developing
you
these
know,
apps
it's,
for.
it's a funny thought. Use dial-up. We do have some teams at Google that, for a day, intentionally slow down their machines.
That's
like
great.
they just have network shaping, where they force their computer to be really slow, because then it like exposes all these problems that they otherwise would not see.
That's great. That's great. We should roll that out everywhere.
Not everywhere.
Upgrade Google Fiber.
Work on both ends. Right. So Lewis in London asked, Chrome and many other browsers open a maximum of 6 parallel connections to each host, referenced on a page. Opera opens 8. Do you see that number increasing in the future for Chrome, Ilya?
Potentially. So there's nothing particularly magical about 6. We basically just run an empirical test where we have a couple of thousand sites that we test on continuously. We tweak that number and we see how fast pages load.
Yeah.
Right?
Yeah.
And we periodically rerun this test just to see maybe things changed. And last time we ran it, which was last year, no. 6 was kind of that sweet spot. Some sites do get better performance if you give them 8 connections, but on average, the performance is worse. So that's why magic number 6 is kind of around, and that's why most browsers use it. So maybe Opera has a particular use case, why they raised it. But if anything, with things like Speedy and HTTP2, we're going the other way because we want you to use just one connection, because that's actually more efficient.
Multiplexing.
Right.
Well, that's a good point. So it used to be 2, right? That
That's
was
right.
like in the specification, it was like
Right.
only no more than 2. So
Yep. And you have
come
techniques like domain sharding where you put stuff on different host names and you kind of work around this whole limit entirely. But that in itself actually creates a lot of problems.
Yeah. It's also a real hack, kind of. I mean,
It is. So it's
hard to
painful in terms
maintain.
of actual development cycle because you need to worry about like what's the magic
Subdomains,
number and all the rest. And if anything, we actually have examples. So Etsy.com actually has an interesting case study where they were over sharding. So they were using too many connections. And because of that, their mobile pages were fetching twice as much data because it was getting retransmitted.
Okay.
Right? And you wouldn't see that if you just look in DevTools. They had to kind of pull up TCP dump and look at the retransmitted packets, and then they decreased the number of those connections, and everything went better.
Okay. Cool.
So measure.
Then optimize.
Then optimize.
Okay, I get it. So another question from Light in China. How can I explore network layout painting in other browsers? So we, in the course, you have Chrome DevTools. Of course, there's IE, Firefox. Tell us a little bit about how. Do you have advice for those?
I mean, search. Look for the documentation, play with it. I'm not sure. I know, Ilya, you're probably better to answer this question than I am. But I think the other browsers have similar tools. But I think the network tab or the timeline tab is pretty unique to Chrome.
Yeah, the tools are different between different browsers.
Sure.
In part because the rendering engines are slightly different, so you'll get kind of different events. But IE has great tooling, especially the latest versions, IE 11 and the rest. Firefox has been doing a lot of great stuff, releasing new capabilities in their DevTools. So if you're using that browser, just kind of poke around. It won't be one-to-one, I can tell you that right now.
No, but it'll be pretty similar, right? I mean, all of the modern browsers have, and even Opera has some great tools. For
I think one area that's been tough in particular is the hybrid apps, where you have a web view, because it's been really hard to kind of reach in and get performance data out of that.
Right.
And you have kind of open source projects that try to do that. That's one of the things I really like about Chrome Web View, right? You just plug in your phone and in Chrome will show you like, hey, there's an app running and there's a web view there. So you can just click into it and it's just like inspecting Chrome. But if you're using something else, then you may need to just kind of search for open source tooling to do that sort of thing. So it's one area that we can definitely improve in.
Right.
But
do you use other tools like external tools?
Yes. So web page test is a tool I use a lot. Not for timeline, because timeline is particular to each and every browser. But the cool thing about web page test is, so webpagetest.org, right? You can come there, give it a URL, and pick a browser, i.e. 10, 9, 7, whatever. I don't have IE7 on my computer, but I use web page test. And then what it does is you can just run a bunch of them and say like, I want to render this page in Firefox, Chrome, and IE, and then it'll show you the network waterfalls and other metadata in a consistent view. So I can just put them side by side and look at like, oh, something odd is happening in this case versus some over there.
Do you find some very interesting cases like that that are just
Oh yeah.
completely unexpected?
Yes.
Okay.
Yes. They're just browser quirks.
Yeah.
Sometimes you have conditional logic in a particular page that says like, if IE do this, if Chrome do that.
Right, right.
And sometimes it's just silly. But
What about, oh, I see, right. What about Wireshark? Do you use that for any of this?
I do, and that's actually another thing that web page test can do. So there's actually a flag that says capture the TCP dump.
Okay. Right.
So like if you really need to delve into the low-level networking bits, so like when did the connection get opened and what's happening in the TLS handshake, you can do that. Or I'm just capturing it directly on my computer. But to be honest, web page test is so convenient that I end up using it most of the time.
Oh,
Yeah,
okay.
that's great. And a lot of the students have been using it on the forums to share timeline traces too.
Perfect.
Right, and that's what you can do with Chrome there, right? Because that's another checkbox. You can say, as you're loading this page, capture the trace, and then you have a URL that you can share. So I guess you could save it and email it to your coworkers or somewhere.
This is almost even easier.
Yeah, right. Perfect. All right, that's great. All right, so next question is from Patty in Fremont. First, it was a full page load. Now it's on load, which is the kitchen sink. What's the next metric on the frontier to take the pole position from onload, start render, or speed index? Also mentioned that speed index, why is it only in Chrome? Is it even in Chrome?
It's not in Chrome.
Okay.
Right. So
let's be honest here.
yes.
But yeah, so what is where do you see that going? What is that next metric?
Right, so first let's define onload, right? So onload is when the spinner stops spinning in a browser, which if we were going for the blank page and then everything's revealed, that's what basically we're measuring at the end.
Right.
What we're talking about here is kind of progressive rendering, right? So we don't want to measure that endpoint. We also want to measure one or multiple points along the way. Like I've loaded, let's say I'm loading a product page on Amazon. It's like the product is visible and the description is visible. Then the comments come in, then something else comes in, and there may be 3 or 4 points that are important. And they're important for that particular app, right? So start render's good in the sense that like something has happened. But what if I just painted white pixels? Like that's a start render. So that could be gamed as well.
Yeah, I guess that's...
So
it's once
I
again
encourage
sort of
developers to think about, or the entire team, kind of the product team, to think about what are the important critical points along that loading path in your application. And that's what the next pole position, if you will, is, right? Because you could say, for my app, it's showing the course page.
Right.
And then the next thing is having the video loaded, right? Like those are the 2 things I really care about.
Right.
And we have APIs in the browser now, things like user timing, where you can just mark those endpoints and say like, the video is being loaded now, or the video has started playing. And you can beacon those to your analytics. That's what you should be doing.
Yeah, that makes a lot more sense.
That's the frontier, right? Perfect. Lewis in London, on Chrome Network Resource Timeline, what exactly does blocking mean? Many places describe it as time spent waiting for an already established connection to become available. And what about when that happens on your first connection to the base HTML page?
So there's actually a good discussion on this question in
the forum,
right?
in the moderator.
In moderator.
Okay.
Basically, what it means is the connection is busy. So this is where we come back to kind of HTTP 1.1. One of the properties of HTTP 1.1 is if the socket is being used, it can be used for any other request. Right. So there's only one request that can be processed at a time. I guess that's what I'm saying. And blocked just means there's something else keeping the socket from doing stuff. So that's what that...
Like those max connections that we talked about.
Exactly, right. So if you're using HTTP 1.1, you only have 6 sockets, unless you're using domain sharding, and all of those 6 are, let's say, fetching things, and then you send the 7th request. Now we're just stuck waiting for one of those sockets to free up. But then there's a particular question about, what about when it happens on the first connection? And that's a tricky one. I would have to actually see the page, but I'm going to guess it's something to do, same scenario, like all the sockets are busy, and we have to cancel some requests before we can send the request. Or we need to run some unload logic. Some pages need to kind of clean up before we can go to the next page, and that could be blocking the execution.
Okay.
I see.
Right. Perfect. All right. So let's see. Same another question from Lewis. My site render start is about 2 seconds. On load around 8 seconds. Inspecting the film strip shows that the page is visually ready at about 4 seconds. So that's actually an interesting question. Like, is there a way to programmatically measure when above the fold is ready?
Well, it's also worth pointing out that film strip here is referring to probably webpagetest.org's film strip.
Yeah,
Right.
Okay.
And you were saying that works by literally taking screenshots of the page as it's being loaded?
So what happens is we record the video, right? And then we sample the video, we basically freeze frame the video, and then we do a visual diff to say, like, have any pixels changed? And if no pixels have changed for a certain amount of time, we say it has finished loading.
Right.
And that's how we give you that progress bar to say, like, oh, you're 40% loaded, 60% loaded, and all the rest. This is why it's also very hard to implement in the browser.
Yeah, right.
Right? Because we're not going to be capturing a video and then doing the diffs. There's been some attempts, but so far they have not been very successful. So I don't know. It's a tricky subject.
Yeah, I guess you could do that yourself and then
Right. So
something in,
the simple answer to this question is use webpage test. Perhaps you could build some stuff on top of it to kind of measure that. So in fact, webpage test allows you to switch in a film strip between visually complete versus document on load. So you can use that. But just do it yourself directly in DevTools. Today, that's not really possible.
And it sounds like also a good use case for user timing. What events are important for your page?
I would actually encourage that instead, right? Because you could define like an important milestone to say the video has started playing on the course page. That's what I care about. Fire an event right there and send it to your analytics.
Back to the next frontier.
Yep, exactly.
All right, so Jordi in Girona, Spain. What's the performance difference between HTTP 10.11 and those over SSL? Why should anyone still use non-SSL pages, and why is Google using 100% SSL web pages?
So there's a lot of different questions there.
So let's start with the Google one. So is Google already doing everything over SSL? It's
not everything, but we're definitely
moving
towards it, and that is an explicit goal across the entire company to move all of our products to 100% SSL. And I'm hoping that'll happen soon, very soon.
So then why should anyone still, that's not at Google, still use non-SSL? There's a great website for this.
Yes.
Answer.
So there's two different questions, right? Like there's the why, and then there's the performance part, which I think is what you're implying. So the why, I think, is no, you shouldn't be using. So everything should be under SSL. SSL provides some nice properties in terms of authentication, making sure that you connect to the right site, nobody can modify it while it's in transit, and it's encrypted, right? So this is actually very important for privacy and security of your site. Right?
So that's good. Why? And then I guess the real question for most people is, and this may be something that they're used to thinking, is, but isn't it slow?
So it's not slow. You may have to just as with critical rendering path, kind of put in a little bit of thought into how you serve it. So that means spending some quality time with your server config or your friendly server administrator to kind of poke him and say, hey, there's
Udacity
these
course in the making.
Perhaps
how to poke a server admin.
how to poke
101.
In the meantime, as we develop that course, there is the site that I've been keeping up to date with kind of all the latest best practices, which is tlsfastyet.com. The answer is yes, and it gives you kind of a list of recommendations for CDN providers, servers, and the different features they support. So the common complaints, or questions I should say, are, doesn't encryption add a lot of overhead? And it can, but modern CPUs are fast enough such that it's not a problem. Google runs everything in software without any sort of dedicated hardware. It's not an issue. Same thing for Facebook and many other companies. The thing you need to be aware of is kind of those extra round trips, because it does take some time to negotiate the connection. So this is where we come back to the discussion between HTTP 1 and 1.1. In 1.0, for every request, you have to open a new connection, which is kind of like, you have to do the TCP handshake, the TLS handshake, which would be incredibly expensive. So you want to make sure that things like Keep Alive work and others. So this is definitely like way down into the networking performance. And that site provides a lot of tips. So
the
yes, run
the
on
website
SSL.
that you mentioned is TLS fast yet JavaScript.com.
That's right.
Right.
And we'll
That has all the tips as well? Or?
Yes.
Okay.
Yes. And
so
a lot
TLS,
of
SSL here, just for those transport layer security, kind of you're using kind of interchangeably.
That's right.
More,
So
right.
SSL is the
Yeah.
original name,
Right,
which
exactly.
was
Right.
developed by Netscape, and then
Now it's-
about 2 years later, they made us an actual spec out of it and called it TLS.
Yeah, exactly.
That's the
Right.
IETF standard.
No, I was just because the question is about SSL.
Right.
Right. And maybe so. The only other thing I'll add is, so Pierre and myself. Pierre is on the webmaster team at Google. Did a presentation on Google I/O in terms of on tips on like
Okay.
if you have a site today, what do you need to do to migrate your site to HTTPS?
Okay.
And what are the things you need to watch out for, both in terms of migrating into HTTPS, like indexing and all the rest, and performance.
Okay.
So that site has a link to that video. So
Great.
definitely check that out.
We'll add it to the moderator if it's not already
Yep.
there. Right, perfect. All right, so now we've come to the final question from Andy Leo in Chicago.
Which you're going to read literally, right?
I'm going to try to read it literally. You have to see this to believe it. There are two examples. Basically, a web page
Yep.
with a hello JavaScript example. One with I guess the difference is there is a title.
So
Or no?
yeah, so this is a very
Yes.
simple page, right? So
Right.
HTML head, there's an inline script that pops up an alert box that
Right.
says hello world. And the
Right.
only difference here is there's a little bit of content, a title,
Yep.
before the script.
Right.
Right, exactly.
So honestly, I would not expect any difference whatsoever in terms of like, yes, if you want to measure in microseconds, I'm sure we
Yeah.
could come up with something, but, and you should measure
Maybe
first.
we can start
Yeah.
running this in a test on their
Right, but for all practical
100 servers.
applications, this won't make any difference.
Yep.
Where it can be important is, so let's say instead of kind of just a short hello HTML, you had a giant HTML comment,
Yeah.
which is,
Yeah,
I've seen
yeah.
that before,
Yeah.
right? And that seems like, well, who cares? Except it does add a lot of content to the beginning of the response, which means it may
yeah.
take more time to fetch those bytes.
Right,
So
right,
those kinds of things you should watch out for, but in this particular example,
Yeah.
unless we're talking microseconds, I would not expect to see any difference.
Well, still, microseconds.
It could matter.
Microseconds matter is a new hashtag.
I think we still need to solve the seconds part.
Yeah. Start with the first thing.
Yeah.
All right, so that concludes the questions we had. So
I think there was one, right?
Oh, that's right. There's another one
Yes,
from
the forums.
from
Yes.
that the students have been
Yes,
struggling with.
the difference I've seen. So I've been spending a lot of time
Yeah.
on the forums,
Yeah.
answering student questions and grading their work.
Thanks for
Yeah, it's fun. It's
Yeah.
good. I used to be a high school teacher, so
Right.
actually interacting with students is way more entertaining than interacting with a camera. No offense. But yeah, so students have been confused between the difference of render blocking and parser blocking.
Okay, right.
So it's important to note that CSS is render blocking and JavaScript is parser blocking. In fact, this is actually kind of funny because when we were filming the course, there was an answer video that I did by myself I checked with Ilya first, but I had the wrong answer actually because I got these two mixed up. So
Okay.
it can happen to anybody. But basically CSS is render blocking because the page won't render until the CSS OM has been built.
Okay.
So nothing's going to show up on the screen unless the CSS has arrived, it's been parsed and turned into the CSS OM. But JavaScript's a little different. It's parser blocking, which means that the page won't continue to parse the HTML that comes after the JavaScript until the JavaScript itself has been executed.
Right.
So everything that comes before it in the HTML can be displayed, it can be rendered, but once you hit that parser blocking script, what comes below it is going to be blocked until that script finishes.
Yeah. And we talk about a couple of strategies in the course for how to mitigate that. So for example, there's the async keyword on
Right.
script that you could add that basically is like an escape clause that says this won't be render or parser blocking.
Right.
That's
right.
the one. I got it.
See?
Escape class.
Yeah. Yeah.
So definitely check out the course. And also there's material on web fundamentals that kind of goes into details and
Right.
shows you examples.
Yeah, there's some great stuff in there. A lot of course notes, instructor notes that give additional information.
Tons of
So,
links. Tons of
yeah.
links.
Yep.
So I think that concludes our Ask the Expert office hour session. Thanks, Cameron. Thanks, Ilya.
Thanks,
If
Peter.
you haven't, of course. If you haven't taken the course, definitely check it out. All of our Google courses that we partnered with Udacity on are available at udacity.com/Google. You can see the entire lineup there. Check out some of the other courses as well. We have courses on mobile web development, HTML5 game development, Android, UX design, app engine. So it's continuously growing. We're excited about all the courses we've put out. And next week there will be office hours on the Android fundamentals course as well as the cloud app engine course that we built. So with that, if you haven't checked them out, do that. And if you have been on the forums, definitely check out the moderator pages for the extra links that we're posting. With that, thank you very much.